Right, so now we are going to talk about a very important theorem in geometry. This is called Pythagoras Theorem. This is fundamental to a lot of geometry and trigonometry and everything. You need this theorem everywhere, basically. You need to understand the meaning of this theorem. So we are going to go through this example, which we will solve using Pythagoras Theorem. So it says find the area of the right angle triangle below. The triangle is given as ABC, where the side AC is 13 units and side AB is 5 units. So let's proceed here. So what is Pythagoras theorem? It says that in a right angle triangle, so right angle triangle is important. This is not true in any other triangle, but only in right angle triangles, where that is one of the angles is 90 degrees. You need a right angle triangle. Then what the theorem says is that the hypotenuse square is equal to side 1 square plus side 2 square. So here in our example here, AC is the hypotenuse, AB, any one of them is side 1. So hypotenuse is the side opposite to the right angle. Is the side opposite to the right angle. AB is, let's say, side 1, and rather BC is side 2. So this important result from Pythagoras, he lived in 6th century BC, I believe. It says that in a right angle triangle, the square of the hypotenuse is the sum of squares of the opposite of the two sides that make the right angle, is fundamental to our understanding of geometry and trigonometry. Okay, so this allows us to calculate the side of the triangle in a right angle triangle if the hypotenuse and one of the sides is given, or if two sides are given. That means the right hand side of this equation, let's call this equation star, is known. If the right hand side is known, that means the two sides are known, then we can calculate the hypotenuse. Suppose we calculate the side BC here. How is that going to help us? So using the theorem we can calculate this unknown side, but if we can do that, then life is easy, because area of a triangle is equal to half into base into height. So we know that in a right angle triangle the base and the height can be taken as the two sides that make the right angle. It's obvious actually from here. So this is the base and this is the height, and this is the base. So if we can calculate the base, we already know the height, and we can calculate the area of the triangle. So we know that AC square is equal to AB square plus BC square. So AC here is 13, AB is 5. So 13 square is equal to AB square, which is 5 square, which is 25, plus BC square, which is something we have to find out. So if we rearrange this, we get BC square is equal to 13 square, which is 169, minus 5 square is 25. This is 144. So BC is equal to square root of 144, which is 12. The numbers are carefully chosen so that you get integer answers here. But even if in real life, if the numbers are not integer, it doesn't matter. You will get a number that is non-integer. You will get maybe something that is it will have decimal points after the decimal point, but it doesn't matter. The theorem is still correct, regardless of whether you get integer numbers or not. So we get finally BC is equal to 12. So coming back to the original problem, so area of the triangle, area of triangle ABC is equal to half into base, which is BC here, into height, which is AB. So which is half times 12 times 5. This is 6, so this is 30 square units. So that's how we can use Pythagoras theorem to do various things with the right angle triangle. You can calculate all the three sides, and then based on the sides you can calculate area, or you can calculate later on you will know about the radius of the circumcircle or the incircle and so on. Once you know the triangle, you can calculate almost anything about the triangle. So this important theorem, I wanted to make a video about it because it's so fundamental that we cannot miss it. Okay, that's about it.